Coming to next subject, I am going to explain about analog electronics. In this analog electronics, the first concept is diode applications. What is diode applications? Simply, the diode application, the most important application of diode is rectification. Rectification means conversion of sinusoidal AC waveform into a single polarity half cycle. The rectification is performed by two rectification circuits. First one is half wave and second one is full wave rectifier circuits. And the most important, the diode application is one clipping and clapping, and the next one is DC voltage multiplication. Now we are going to another section, that is diode approximations. And in these diode approximations, first of all we see that what is ideal diode, what is second approximation, and what is third approximation. See, now we are going to see the diode approximations. Here friends, the first one is ideal diode. In this ideal diode, what happens means, when diode is forward biased, the resistance offered is 0. When it is reverse biased, the resistance offered is infinity. It acts as a perfect switch. And see here, the diode forward biased, resistance offered is 0. And when reverse biased, resistance offered infinity. So in this case, reverse biased resistance is offered infinity. For this case, it is exactly act as a switch. And the characteristics of ideal diode. Here it is the characteristics of ideal diode. ID and VD. See, this is the exact characteristics of ideal diode. Here it is VD, and the symbol is like this, diode. Next we are going for second one is second approximation. Here the thing is that when the voltage is more than 0.7 volts in forward bias, it connects and offers 0 resistance. It conducts and offers 0 resistance. The drop across the diode is here. Drop across diode is 0.7 volts only. The reverse biased application, it offers infinity resistance. Reverse bias applications, it offers it offers infinity resistance. So, and here what is the characteristics on equivalent circuit of the second approximation? See, this is the circuit and this one is the characteristics of. This is VD, this is ID, and here 0.7 volts, and this one is the, and here it is the symbol for diode approximation to 0.7 volts. It is the, this one is the second approximation 0.7 volts. This is diode. Okay, now we are going for the third approximation. Here, third approximation. What is third approximation? This one is also similar like second approximation. Here again we are giving forward bias more than 0.7 volts, then the diode conducts. Diode conducts and the voltage drop across diode becomes 0.7 only, and resistance is RF. This is the forward resistance, and the VD equation, the VD equals to 0.7 volts plus forward resistance and current at diode. The characteristics and equivalent circuit of this diode is here. See this one. volts. This is VD and this one is ID. A similar diagram is, this is 0.7 volts and this is forward resistance, and this one is diode. Now we will see one example. Calculate the voltage output of the circuit shown in figure. This is V out, this one is V1. This is R. So this one is RS and this one is RS. This is V2. And some questions be A. V1 equal to V2 equals to 0, and question B, V1 equals to V2 equals to V, and question C, V1 equal to V2 equals to V1 equals to V and V2 equals to 0. This is the question, and for resistance for each diode is RF. forward resistance for each diode is RF. Now we will go for the solution. When for the question A, when both V1 equals to V2 equals to 0 means then the diodes are unbiased. So therefore output voltage equals to 0. When unbiased diode means the output always comes 0. And now we are going for second one, B. V1 equals to V2 equals to V. Here what is the output for V1 and V2 and V3? Coming to this, the V1 and V2 are same as V. Both diodes are forward biased and conducts. So for this one, how the output circuit will become? See, this is the output circuit for the this is V, this is the voltage one, and VR, this is R, S, and this one also 4S, and this one is forward resistance, this one is forward resistance, this is the current flow symbol. This one is the circuit for equation B when V1 and V2 are equal. So now what is the equation we will get for the above circuit? The equation is V equals to I RF plus RS plus R plus VRF. This is applying KVL we get, and now therefore V equals to half RF plus RS plus VR plus 1. Why we are getting here half means because we are applying voltage to V1 and V2. When we are applying the voltage at V1 and V2 side, both voltages will be equally and applied at equally. That's why we get here half. And for the current equation is V minus VR by RS plus RF by 2 plus R. This is the V when the equation is V1 equals to V2 equals to V. Now we are going for third equation, that is C. C is V1 equals to V and V2 equals to 0. For this condition, the circuit will be similar. For this, we are applying KVL to we get same one V equals to I RF plus RS plus R plus VR, and I equals to V minus VR by RS minus RF plus R. This is the voltage and current equations for the equation V1 equals to V and V2 equals to 0. In this condition, V1 equals to V and V2 equals to 0, then the upper diode, this one, the upper diode is forward bias and lower diode, this one is unbiased. For this, the resultant circuit is this one. Thank you, friends.